Hello, and I'll be doing my presentation on the Hubble Space Telescope, the work that went into launching it, as well as what it achieved following its launch. The idea for the Hubble Space Telescope originally came from a problem. Scientists couldn't get clear images of distant planets and other celestial objects. Earth's atmosphere would bend and interfere with the light reaching telescopes on the ground. As such, the idea for a space telescope was drafted up. Theoretically, a telescope in space would have no problems with observing far-out objects. The scientists' hypothesis proved to be correct, as the Hubble Space Telescope would provide the clearest images of some of the farthest celestial objects known to man. The idea for a space-based observatory was first proposed in the 1940s, but it wouldn't be until the 1970s that the project would gain traction. NASA and the European Space Agency, also known as the ESA, joined forces to develop what would become the Hubble Space Telescope. The concept aimed to overcome the limitations of ground-based telescopes caused by the interference of Earth's atmosphere. The design and construction of the Hubble's telescope involved a large team of scientists, engineers, and technicians. The Perkin-Elmer Corporation was responsible for building the primary mirror, while various contractors and institutions contributed to other components and scientific instruments. The Space Telescope was originally scheduled to be launched in 1986, but was delayed following the Challenger incident. 4 years later, the Hubble Space Telescope would finally launch, successfully being placed in an orbital trajectory in 1990. Unfortunately for the telescope, a design flaw in the primary mirror resulted in any images the telescope produced to be blurry. This setback threatened the success of the mission, but ultimately, a team of engineers and astronauts performed a series of complex spacewalks in 1993 to install corrective optics, known as the Corrective Optics Space Telescope Axial Replacement System, or COSTAR for short. Following its launch, the Hubble Space Telescope achieved a great many groundbreaking scientific discoveries and observations, all of which revolutionized our understanding of the universe. One of the most incredible of these discoveries was the deep field observations in 1995. Hubble conducted a series of deep field observations where it captured a small patch of seemingly empty sky for a total of 10 days. This empty sky was about the same size as the width of a dime held 75 feet away. In short, an incredibly small portion of the night sky. Nonetheless, the image taken revealed thousands of galaxies at various stages of evolution. Some galaxies captured in this remarkable image are thought to be over 10 billion years old, dating back to nearly the start of the universe. The Hubble Space Telescope has captured fascinating images of supernovas and nebulas, providing insight into the formation and death of these stars. These observations improved our understanding of how stars evolve and disperse elements into space, as well as showing us the formation of protoplanetary disks, which are disks of swirling matter which eventually condense into planets. Hubble has also discovered several exoplanets, that is, planets outside of our solar system. It helped in measuring the atmospheric composition of exoplanets and provided certain evidence for the presence of water vapor in the atmospheres of certain exoplanets. It achieved this through analyzing the wavelengths of the light filtered through the exoplanet's atmosphere. During an exoplanet's orbital cycle, eventually it is placed between its parent star and Earth. This means that the light from its parent star must travel around, and in some parts through, the atmosphere of the exoplanet. The color of this light can provide insights into what elements make up the planet's atmosphere. The presence of water on these planets could signify the potential for life as we know it to exist on them. The Hubble Space Telescope also provided valuable insight in observing and studying gravitational lensing. Gravitational lensing is a phenomenon where the gravitational fields of massive objects can bend and magnify light from more distant objects. Through using gravitational lensing, Hubble can observe and study objects that would otherwise be too faint or distant to detect. All in all, the Hubble Space Telescope is responsible for much of today's knowledge regarding distant celestial objects. Unfortunately, the telescope is in a very poor state. Many of the original gyroscopes have failed over the years. Without them, the telescope is unable to position itself to observe distant objects. However, the James Webb Telescope promises to be a suitable replacement. The James Webb Telescope is over 100 times as powerful as the Hubble telescope was, and, as such, I am very interested to see what the telescope can discover.